I'll start by telling you a story. It's a true story. So meet Jure. Jure is a mechanical engineer, and he works at the Institute for Innovation and Development of the University of Ljubljana. So during his education, he said that his mind got very technical, and his skills were very technical. And in this engineering bubble that he was in, as he calls it, he didn't think much of social sciences. He perceived them as not being very useful or relevant for his research. He's an expert otherwise in energy efficiency and building automation and integration of renewables in buildings and energy information systems. Being in his engineering bubble still, he started working with anthropologists, and they discussed methodology, they talked theory, they planned research, and they carried out research together in a highly automated building. And what Jure discovered during this research is that, because he used to say that buildings use approximately 40% of total energy, he now switched his mind and he says that people are actually using energy in buildings, and that buildings are built for people, and that we should start including them in the research, in the design, in the building, and in projects that are related to those buildings. And he said, why shouldn't we include them into all these processes? And so they did. The people-centered development approach is still being used in other international EU-funded research and development projects, such as Mobistyle and AAA Reno. Whereas some other engineers were quite concerned and suspicious of our anthropological approaches. For instance, when we said that we will do deep interviews with 30 building occupants, they said that, but this couldn't be statistically relevant. How can we build meaningful technologies on data sample of only 30 people? But Jure realized that this kind of research, ethnographic research, combined with his and others' engineering perspectives, actually yielded excellent results. And now Jure already sometimes assumes the role of an interpreter between social scientists and engineers or architects in the research teams. And he says now that he's not actually a mechanical engineer, really, but he's a people-centered humanistic engineer. Something similar also happened to the anthropologists in the team. So today, I would like to explain how we brought together social sciences and engineering, and university, higher education, research, and industry in an EU-funded project called People-Centered Development Approaches in Practical and Learning Environments, PEOPLE. I'm also a member of the PEOPLE team. I'm working as a researcher in a Slovenian company called Medtronic, which specializes in automation systems and IT solutions for digitalizing industry, smart buildings, and critical infrastructure. I will first explain the rationale of the project and the ideas behind it, and then I will present the Slovenian case study in more detail. But my overall goal is to share how our experience in interdisciplinary and cross-sector work can bring about positive change on different layers in teaching, in learning, in research, and in business and industry. So the People Project has 4 nodes or partnerships in 4 different European countries: the United Kingdom, Czech Republic, the Netherlands, and Slovenia. And each of these nodes is constructed of two partners, higher education institution or research organization, and an industry partner from the energy efficiency and sustainability field. These are the identified challenges on both sides of the core to stakeholders. So higher education, we focused on the domain in social sciences and humanities, in particular anthropology, sociology, and psychology, but also other related fields. So the challenges that we wanted to address were the skills mismatch and unemployment of graduates in those fields, highly theoretical and discipline-oriented, discipline-related subjects, methods-driven academic culture, a lack of cooperation with the business world to identify the real-life challenges. On the other hand, on the industry side, some challenges were like environmental challenges and energy consumption, business usually dominated by technical engineering, technological developments that ignore behavior, habits, practices, values of people, and in general, a lack of knowledge about people-centered design and development approaches and methods. So the solution that was designed within the people projects were the people-centered learning cycles. Those are interdisciplinary projects that are focused on real-life, industry-relevant cases and involve experiential learning and skills development and entrepreneurship. So I will show you a short video.
Climate change and global warming create challenges that put companies under pressure to come up with new solutions for sustainable living and energy. Often, development and implementation of these innovations are dominated by technical engineering. But what about the social sciences? We need to think about the people that are meant to use these innovations and make sure that they fit their needs, everyday life, and practice. People-centered development does just that. It keeps in mind that people should be an indispensable part of industrial development processes. With the People Project, we address this, as well as the underemployment of graduates of social science studies. In 4 European countries, we connect interdisciplinary groups of students, industry professionals, and educators to work on real-life business challenges in sustainable living and energy. This allows social science students to develop practical competences towards employability, helps industry professionals integrate social science expertise in their practice, and enables educators to develop better engaged social science learning in higher education. The key innovative contribution of the People Project is the implementation of people-centered learning cycles. These consist of several phases. In the first phase, we prepare all team members. Industry professionals share their business challenges, students formulate their research plan, and together they follow a training on people-centered development. In the second phase, research begins. Students conduct field work amongst people relevant to their case study. Citizens, residents, consumers, men, women, children. Our students interview and observe them, get to know their needs, habits and lifestyles, and actively involve them in the development process. Next up is the analysis. What does the data tell us? What is relevant for people when it comes to sustainable living and energy? Our students write their thesis and they formulate their recommendations in a fit-for-industry product, sharing their research and results with academia and industry. Finally, all European participants in the People Project come together to exchange ideas and share their results and experiences during a 2-day co-creation camp, enabling an even stronger and broader collaboration between higher education and industry. Are you interested in people? Do you want to know more about people-centered approaches and co-creation between education and industry? Go to our website and follow us on Twitter and Facebook.
There are 4 phases. The students are supervised or mentored by the higher education staff as well as industry representatives. They prepare for the research, they decide what the case study will be, they create a research plan, and they all participate in a training. And then they carry out people-centered research, they analyze their data, and finally they present their results to the industry partner or include them in their thesis. But what do we mean when we say people-centered development approaches? We present this process which is focused on innovating, designing either new products or new services or processes as a four-step approach. And what usually happens in industry is that the first two steps are left out. So the product starts being developed in step 3. So industry staff, business representatives meet up and decide what kind of technology they will develop that will somehow help people. Then when they have a prototype, they start testing, and then they try to figure out what does it mean to the people, how it could be used. And this is the traditional linear way of developing new technologies. So starting from existing technology, developing a product, and then looking for meaning. Whereas in the people-centered development approach, we first start by identifying the meaning, and it is always based in qualitative research using people-centered methods. Interviews, focus groups, participant observation, and so on. And from this analysis that is highly grounded in qualitative research, we can then move forwards to designing a new solution, be it a product or a process. So in this scenario, technology is a thing that enables people to do something, that enables a better possible future. Perhaps I'm quite sure that there are some designers today in this room, and some of you might be thinking, okay, so this sounds a lot like design thinking, so what's new? There's been a lot of critique of design thinking from the designers as well as from social scientists, but maybe if we look at this map of design practice and design research designed by Liz Sanders, we can see that the people-centered development is placed somewhere in this part of the map, which means that it has a very participatory mindset, where the users, or people as we prefer to call them, are seen as partners. So they are active co-creators in the development and design process. And it is also very much research-led, so it is grounded in anthropological or social science methods and approaches. So I will now move on to presenting the Slovenian case study and what the Slovenian students and other team members did in Slovenia during the first people-centered learning cycle. Just to start off, I wanted to point out that buildings use roughly 20% of total final energy consumption. And our case study was this. So, once upon a time, back in 2014, the University of Ljubljana completed the largest investment in its history. The building which houses the Faculty of Computer and Information Science and the Faculty of Chemistry and Chemical Technology. It's one of the biggest investments in the history of Ljubljana, University of Ljubljana. It was worth over 80 million euros. And it's probably one of the smartest buildings in the entire region. And it features 600 rooms with very diverse intended use. So the project envisaged also a construction of a very complex central control system, and the implementation and building of the automation system was entrusted to the company Medtronic. So Medtronic's central control system, which is installed in this building, includes the management of all systems and devices that are in any way related to energy consumption, from the boiler room to the heating system, cooling system, air conditioning, ventilation devices, and even lighting in each individual room. So over 500 rooms are equipped with devices that ensure indoor environmental quality levels, and there are over 20,000 input-output points controlled by this system. And these are also coordinated with external systems. This means that the SCADA system, which is the supervisory control and data acquisition system, can communicate with other systems. This is how, for instance, the control computer sets the position of the outdoor window shades based on the position of the sun in a particular moment. So this basically means, in lay terms, that the building knows everything. It knows when someone is in the room, it knows when someone's clicking on the thermostat, when someone is opening a window, it knows the exact temperature and air conditions in each of those 500 rooms. And so basically, the building is super smart. And this serves three very immediate purposes. These are the energy efficiency in the building, the indoor environmental quality, and of course safety. Since it also houses the faculty of chemistry, you can think in terms of chemical lab tests gone wrong or similar things. But another system that is installed, which is an energy information system, also stores and processes all this big data that is getting gathered. And it can provide the building manager with an opportunity to analyze energy use in the building, predict and improve the energy efficiency. So since the building is so super smart, can the building occupants just sit down and relax? Let's see. You probably noticed that the people disappeared from this presentation on the people project, so let's bring them back in, which was exactly what was the role of our students and our research team in the people project. These are some of the questions that they set off to research during this first learning cycle. The students worked individually or in pairs, but they were convening regularly on meetings and sharing their experiences and results. And the sheer amount of digital data that gets collected and processed by this system has a wonderful potential to explore what is happening in the building and what its occupants are doing. But a large proportion of this data gets stored without being researched or utilized in any way. So our methodological goal was to contrast big data with thick data. So to explain this visually, this is a poster on one of the walls in this building. And on the left-hand side, we can see what could be represented as big data. But if we look closer, we can see that this picture is actually made up of very tiny profile pics of all faculty employees. And so in our ethnographic approach, we intended to see the building from up close. So what does this particular person here think about the building? How does she feel inside it? How does she experience the room? What are her daily practices when she gets into her office every day? And is she happy that her external outdoor shades are regulated automatically? So the students experimented and tested with different methods and approaches, starting off with a questionnaire sent to all employees and students in the building and continuing with interviews, observation, focus groups, and so on. One of the students involved in this research, who is doing a PhD in anthropology, is also a researcher in data mining. So she attempted to combine those two approaches, analyzing big data, but also doing qualitative ethnographic research on the same topic. For example, the system data analysis could well provide us with an answer to what is happening in the rooms. But it could not possibly provide us with an answer to why this is happening, why a particular pattern is occurring. Why do researchers in a chosen research lab room, for instance, always open their windows at a certain time of the day? Why did they adjust the temperature? These are the kind of questions that qualitative ethnographic research could provide answers to. We could otherwise only speculate. But the very first surprise in this research was provided by the initial questionnaire which was sent out to everyone. It was supposed to get the students some baseline data about how everyone in the building feels and experiences the building. As the response rate to such questionnaires is usually not very high, we set our expectations fairly low, but were we in for a surprise? We received over 600 responses and had a 30% plus response rate. And since most of the questions also had space for open-ended comments, we received also a massive amount of additional explanations, some of them quite agitated, while admittedly some of them also quite unrelated. E.g., replying to a question regarding indoor environmental quality, someone explained that what in particularly bothers them is the low quality of interpersonal relationships among the employees of the university. So while some of the comments were positive, there were a lot of them that were quite fierce. Here are some examples. There's a lot of exclamation marks in some of them. In particular, this one seems very interesting. But rather than understanding these comments just as direct critiques of the building and its automation system, we saw this number of responses and additional inputs as primarily a sign that this topic is very important to the building occupants, and that they might not feel comfortable with the fact that they have very little control over the building. And it was probably just a fact that no one has ever asked them to share something about their experience in the building. So at the end of the research, the students had to prepare a presentation of their findings and recommendations for the project industry partner. This actually proved to be the most difficult part of the journey. Although their insights into the people side of the building were really exciting, ethnographically speaking, but how can we translate those findings into something that could be useful and relevant for the building automation industry or the university management, for instance? So the students realized during this process that even though anthropologists can provide valuable insights into the context and broadness in terms of understanding what happens inside a building, and at the same time, the strength of their methodology is to look quite microscopically into individuals' practices and needs. This can at the same time quickly lead our research much wider or even away from the narrower questions that are in the interest of the industry. So anthropologists can sometimes quickly shift the focus of their study, allowing the field or the people to guide their research, which is what we are actually taught at the university. Although in an industry environment this might seem like a weakness, it is because useful results are expected immediately. It is exactly this approach that can lead to new discoveries, as we don't only set out to find answers to the questions that are of interest to the industry, but rather we instead try to find questions that are relevant to the users, the people. And this is actually the crucial point that has potential for innovation in industry or government and policy. So this was one of the really valuable curves in our experimental teaching and learning approach. Anyway, the students managed to formulate 5 development recommendation points based on their research, and they successfully delivered their presentation to the Medtronic management and staff. So I will conclude by focusing on the impact that this experiment in teaching and learning had on all 3 groups involved. In particular, I'm interested in how the students experience this non-traditional way of learning. And in their final assessments, final essays, evaluative essays, they particularly were able to formulate an idea of what role anthropologists can play in industry. They also experienced the different way of doing the learning as very beneficial, since the project was never, the learning was never inside the classroom. It was always outside, in the field, in the building where we were doing the research. But in particular, the interdisciplinary dimension proved very valuable to them, and they were able to recognize this, how the diversity of approaches can actually bring better results. So besides being a researcher in industry, I also work as a researcher at the Institute for Innovation and Development of the University of Ljubljana. So the Institute is the coordinator of the People Project, and it was established by the university and 9 leading Slovenian companies with a goal to provide a link between higher education and research and Slovenian industry. So one of the key roles of the Institute is to implement interdisciplinary scientific research, development, and also professional projects. So interdisciplinarity and cross-sector teaching and learning are the underlying common thread throughout the People Project as well. So as there were clearly benefits for the students, it was also a novel experimental method for the educators in the higher education and research. And industry professionals were also able to identify the potential of the people-centered development approach. And we are successfully now integrating this successful approach in a new project, which is also funded by the Erasmus Plus program, whereas we are in this project focusing on city challenges and working with city authorities or relevant other actors in urban areas. And since the first learning cycle and the 4 different case studies were kind of our test and trial and evaluation, we are now, this year, currently continuing with 4 new case studies in all 4 countries that are involved in the project. For instance, at Durham University, the students are researching how the Durham County Council could support development of e-mobility in Durham City. And to conclude, what was the thing I wanted to say? It's not just about the project. What we are looking further into the future, and our idea is to design an international MA program that would be interdisciplinary and would focus on people-centered development and design approaches, connecting different academic institutions and hopefully Australian ones as well. Okay.